Hello ladies and gentlemen. Today I'm trying to repair our Dyson battery powered vacuum cleaner. We have it for about 2 to 3 years and the battery is gone bad. You could get these batteries on the internet for about 40 to 50 euros, but I'm going to try and repair the battery by switching to new cells. I'm not sure how well this will work, and honestly I doubt that it will work, but I'm going to explain this later. The problem the vacuum cleaner has is that when you power it switches off after a few seconds because the battery isn't any good anymore. I'm going to take off the filter housing and then we're going to remove the battery. Okay, so to remove this battery we have to remove this screw and the screw on the handle in the back, and then the battery should slip out. And it does. By the way, a short disclaimer, you're doing this all at your own risk, and I would recommend you don't do this at all. I'm not sure if it's worth the effort or if it will actually work, but I warn you. For opening, I'm going to use this metallic scalpel shaped tool. I'm going to pry or try to pry the plastic here open. I'm going to place some sort of credit card or ID card in here to hold it open. And then I'm going to try to open the front side. Be aware that poking with metallic stuff inside battery packs is maybe not the brightest idea. Here's a hex screw. Should have looked at this a bit better. Okay, we are finally open here. Was a bit of a mess. Now we can see here's a switch that switches the battery pack, or that shows the battery pack if it's plugged into the vacuum cleaner. I'm going to see if I can get this out without destroying everything. Here's the spring. We are in now. I haven't found out how to get the loading connector out, but that shouldn't be a problem. When you have undone the 6-8 clamps in the front, you can switch this, you can pull this off, and then there is a LED light diffuser screwed on here. You have to put the hex screw out, and then the battery pack gets out. Inside the battery pack is what I've already thought there would be. Here are 6 18650 or something. I will put the description in the info box, which are connected in serial. And here are the terminals where the negative and the positive part are going to the PCB. You can see that here because the traces here are much bigger, and in between them there are 5 smaller traces. These are for the balancing of the battery pack. With these lids, the battery control unit, which is this PCB, can control and measure the performance of the batteries inside. It can load every cell to the maximum value. This is used because the batteries can unload and load uneven, which basically means if the battery cells inside this pack have a different internal resistance, then they could charge uneven if you or when you only charge it from the output ports. So therefore there are the balancing ports. I'm going to show you what I mean. If we, I hope you can see this here. If we measure the voltage between the 2 big terminals, you can see that we have a voltage of about 24.2 volts. And if we measure the voltage from the negative terminal to the balancing terminals, we can start by this one here. Here you can see 4 volts because you measure here the ground and here the batteries are connected. Therefore you have 4 volts here. This is the voltage of a single cell. The battery is here connected with this one. This means here we have 8 volts. That means 2 cells. On the back here we have 12 volts. Here we should have 16 volts. And here we should have 20 volts. And here we have the full voltage of the battery pack. This is already a bit suspicious. I'm not sure if this will be successful today. The batteries are quite full, in my opinion. I know that I don't draw current from them, but they seem to be quite fully charged. And also I assume that the battery management unit over here will not let me put in new batteries, which either it When I put in the new batteries, either it won't supply the voltage to the connectors here, or it will not load the batteries, but we will find that out. Another thing I want to try is measure the voltage on the terminals here. Here you can see we have no or almost no voltage. And when we press this button, the voltage goes up to the full 24 volts and then down again. So the first thing I'm going to do is I'm going to cut these connections here, and then I'm going to put out the old batteries. As I said, be aware that this is not to fool and play around. The batteries are loaded, they can explode, they can if shorted out, and this is not the best thing here. So I'm going to cut these, put out the old batteries, and then we are going to see. I'm trying to do this with this side cutters here. I'm also going to bend the balancer leads out a bit so that they are not in my way. Here you can see that the unit has sensed a problem here. It's blinking red now. Here we have disconnected every balancer line. I'm sure it's checking the state of the single cells. Also a good thing to do here is mark where the batteries, the polarity of the batteries should be. So here we have the positive and here we have the negative terminal. Okay, we have opened every connection here. Now the batteries should be quite easy to pull out. Okay, the old batteries are out now. As I said, make sure they don't short out. And now we are going to put the new batteries in. Here are the new batteries. They look like the old ones. I'm going to measure the polarity, although here should be the positive side and here should be the negative side. But I'm going to make sure. Yeah, this is correct. The batteries are preloaded to 4 volts. And now I'm going to put the batteries in the old housing here. I hope they fit. If we've done everything correct, we should see opposing colors on each side, which it is. And basically we are going to solder these flags together, and these flags together so that we get a serial connection battery pack. And then we are also going to solder the balancing lines together and the main current lines. Please be aware that these are all loaded batteries, and try not to make a short circuit. I'll do my best. Okay, now that we've soldered everything together, we are going to check the voltages. Here on the first battery we have 4.0 volts. Here we have 8 volts, 12.12 volts, 16.16 volts, and 20.19 volts, and the whole battery pack has 24.28 volts. This is as it should be. Now if we are going to measure on the output pins. Okay, here the green LED blinks, and we also have the 24 volts here. Just for your interest, the loading power supply is 26.1 volts DC power supply with only 780 milliamps, which means all the logic for charging the internal batteries are done by the battery maintenance unit here. I would actually be really surprised if this would work. I've tried to change the cells on different battery power tools now, and normally the BMS units won't work or won't let any current out anymore if you've changed them. I'm really curious if the vacuum will work and if it also will charge again. Okay, now the only thing left to do is put it back into the housing and see if it works. I'm going to check the voltage again. So if I press this button here, the voltage is 24 volts, which should be okay. Now I'm going to put together the front side of the battery pack. I make sure that the cables inside don't get tangled or broken somewhere, and then I'm just going to slide it together. We have the screw with the hex head here. I'm going to put these in, and it looks quite good actually. I put in the left the screw behind the grip here and the screw in the front, and then I can check the vacuum. I'm going to try the vacuum. Normally it should at least work as it is because the batteries are new, and then I'm going to check if it actually loads. Okay, I've cleaned the bench a bit, and now we're going to check if the vacuum works again. Well, Okay, obviously it has the same issue as before. The battery blinks for 10 times, which means that the battery is empty. I have loaded or charged the batteries before assembling. So my assumption is that the battery management unit in the battery pack has saved the error and doesn't let the vacuum work. This is common practice by battery powered tools, I'm afraid. I'm going to let the vacuum cleaner charge overnight, and then I will check this tomorrow, and then we'll see. Okay, so I have charged the battery of the vacuum overnight, and now we will check if anything happened. Okay, apparently there is the same fault as before. You can see here that the LED is blinking. This means that the battery is ran out of power, which is not possible because I pre-charged them before putting it into the case. I assume that the battery management unit inside the battery pack has saved the fault from the old batteries, and therefore it wouldn't work anymore. But I'm going to test and hook the battery pack up to a lab power supply and check what is happening there. Therefore I'm using a normal barrel connector that fits into the plug here. I'm going to check the polarity of the barrel connector. The power supply of the vacuum itself is center positive, which is here also the case. So I'm going to set the voltage and the current on the power supply. The voltage from the original supply is 26.1 volts and the current is set to 0.78 0.78 amps, and I'm going to start now and check how much current it is drawn. As you can see here, the power supply went into constant current mode and the current is all up to the value we set. You can also see here that the battery is charging, and now you can see that the something inside the battery pack switched off because the current went to zero, which basically means that there is no power going in anymore. To be honest, I thought about this before doing this job, and I knew that there was a possibility that this would not work. The problem here is the battery management unit. I'm not sure if it is defective or if this is normal behavior. As far as I see it, the battery management unit locks out the battery after some fault is detected. It may also be that the battery management unit counts the loading cycles and switches the battery off after some time, because I don't think that the old batteries are really broken. I will do some tests when I get my hands on a decent DC load, and then I'll see how much capacity these batteries really have. As far as I think, or as far as I know, this is a common problem. I have searched the internet before. There are battery management units sold for this type of battery pack. They cost about $20. If you add the $10 from the battery cells itself, you're at $30, and a new battery will cost you between $40 and $50. So it's totally not worth the effort that I've done. Yeah, so basically I spent an hour to change the cells and nothing came of it. You could theoretically rip out the battery management unit, solder some wires and a connector to the balancing leads, and charge the battery from an external battery charger. This would be possible, but you also have to think that you have to shut the battery down, that you don't unload it too much. So this will also be a lot of effort for this, and yeah, that's basically it. I would be really curious if you have some advice. You can post it in the comments below. I'm going to put this on the shelf for now. I'm not going to say that Dyson has designed this battery pack to fail, but it stinks a bit. The issue is that I'm pretty sure, as I said, the old cells aren't really dead, and that the battery pack or the battery power unit or management unit won't let you to reset it. So you have to throw away a perfectly good battery pack after some time. So thank you for watching. I hope this helped you, and I hope you don't have to disassemble this as I did, because not much came of it. And thank you for watching, and please write some comments if you have some thoughts on this. Bye bye.